Hi students, this is Viswanath, Chemistry faculty for NEET and IIT exams. In last class we completed radius expression. That means expression for the calculation of radius of the orbit. Now continuation part of Bohr's model. Next point. According to Bohr's model, energy levels or shells are represented by n equal to 1, 2, 3, so on. Otherwise capital alphabets, capital letter alphabets K, L, M, N, so on. That means K shell means first orbit, L shell second orbit, M shell third orbit, N shell fourth orbit, like this. In this way, by these two different symbols we can use to represent energy levels in the atom. Now numericals related to radius of the orbit. Say this numerical, which state of Be3 plus has the same orbit radius as that of the ground state of hydrogen atom. In the hydrogen atom, ground state radius having a particular value. In Be3 plus ion, which energy level having same radius, that we should find out. See the answer. Radius expression for ground state of hydrogen atom, R1 equal to 0.529 angstrom units. Actually formula radius of nth orbit, Rn equal to this one, 0.529 into n square divided by z angstrom units. Here for hydrogen atom ground state means n value 1, so R1 equal to, here n square means 1 square divided by z, atomic number of hydrogen is 1, so z value 1. So finally we can get for ground state in hydrogen atom radius expression R1 equal to 0.529 angstrom units. Now for Be3 plus ion radius is, this is the expression, Rn equal to 0.529 into n square by z angstrom units. What is the given condition? Radius of the Be3 plus ion is equal to radius of ground state of hydrogen atom. So these two should be equal according to given data. For this formula is this one. For this R1 means this value, substitute here, then we can get here beryllium ion, Z value, atomic number is 4, so the Z value 4, substitute, these two get cancelled, then we can get n equal to 2. That means in Be3 plus ion, second orbit radius is equal to that of radius of the first orbit in hydrogen atom. So option B is the answer for this. See the next question. The distance between fourth orbit and third Bohr orbits of He plus is, fourth orbit and third orbit distance we should calculate. For that, say this one. Formula, radius formula for nth orbit, Rn equal to 0.529 into n squared by z angstrom units. For fourth Bohr orbit of He plus ion, that means radius of fourth orbit, R4 equal to 0.529 into n value 4. Helium means z value 2, then we can get this x value. For third orbit of He plus ion, R3 equal to 0.529 into 9 by 2. Now distance between fourth and third orbits, that is R4 minus R3, subtract this, then we can get this one, 1.851 into 10 power minus 10 meters. Then what is the option? Option C is the answer. Okay, so these are numericals related to radius. See the next one. If radius of second stationary orbit of hydrogen atom is capital R, then radius of third orbit will be. In hydrogen atom, second orbit radius is capital R, then what is the radius of third orbit? Say this one. For hydrogen atom, radius of second stationary orbit R2 equal to 0.529 into n square by z. So n value 2 square by 1, that equal to this. Given this value R2 is equal to capital R, so equalize this value to capital R, then we can get this one. Radius of third stationary orbit is R3 equal to 0.529 into third orbit means n value 3. So 3 square divided by 1. So we can get this one. So in place of 0.529, see here, can we write R by 4? Yes, we can write R by 4. So R by 4 into 9. So by doing calculation, we can get 2.25 R. Then what is the option? Option D is the answer for this. Okay, next. So these are some of the numericals related to radius of the orbit. Now see the continuation part of the Bohr's model. From this Bohr's model, we can calculate kinetic energy, potential energy and the total energy of the electron in a particular orbit. See the formula for them. From Bohr's model, we can calculate kinetic energy, potential energy and energy of the electron. Kinetic energy of the electron half mv square equal to ze square by 2r. Potential energy of the electron equal to minus ze square by r. Total energy of the electron EP equal to ke plus pe. So kinetic energy expression, this is potential energy expression, then we can get this one minus ze square by 2r. So total energy equal to, see the relation between total energy and potential energy, minus Pe by 2. Relation between total energy and kinetic energy is Et equal to total energy Et equal to minus Ke. Remember these formulae, based on this numericals are there. Now energy expression, En equal to minus 2 pi square mz square e power 4 by n square h square. M is mass of electron, H Planck's constant and orbit number, Z atomic number of the species, E charge of the electron. Okay. So remember this important point, as we go to higher orbits, kinetic energy decreases, potential energy increases and total energy increases. Many of the students will get confusion in this point. So remember, this point is very important. As we go to higher orbits, kinetic energy decreases, potential energy increases, total energy increases. Okay. Next, energy of orbits in hydrogen atom. By substituting m, e, h, pi, all these things, by doing calculation, final expression we can get minus 2.179 into 10 power minus 11 divided by n square ergs per atom. In terms of joules, this is the formula. This is the value, minus 2.179 into 10 power minus 18 divided by n square joule per atom. In terms of kilojoules, minus 1312 divided by n square kilojoule per mole. In terms of electron volts, minus 13.6 divided by n square electron volt per atom. EV means electron volt. And kilocalorie per mole value is minus 313.6 divided by n square kilocalorie per mole. So this is the value for energy of the orbits in hydrogen atom or hydrogen like species. Now see the next one. Energy of orbits in species like hydrogen atom. En equal to minus 2.179 into 10 power minus 11 into z square divided by n square ergs. So En equal to En equal to E1 divided by n square into z square. Here E1 means this one. In case of hydrogen atom, z value 1, for first orbit n value 1, then we can get this one. That's why in place of this value we can write E1. So here En is the energy of the nth orbit, E1 is the energy of first orbit in hydrogen atom. N value 1, 2, 3, 4, so on. Z equal to atomic number. So for related to energy of the electron, this expression we use in numericals. So remember it carefully. En equal to minus 13.6 into Z square by n square electron volt. Okay. So the relation between the ratio of potential energy, kinetic energy and total energy is minus 2 is to 1 is to minus 1. Important this, remember carefully. Potential energy, kinetic energy, total energy ratio minus 2 is to 1 is to minus 1. So this is the derivation related to this ratio between potential energy, kinetic energy and total energy. Next, numericals related to this energy expression. See this. Transition of electron from M shell to K shell results in the formation of spectral line in. Already we know that K shell means first orbit, M shell means third orbit. Third orbit to first orbit means spectral lines formed in Lyman series. Lyman series is observed in UV region. So option A is the answer. Next, an electron in hydrogen-like species jumps in such a way that its kinetic energy changes from x to x by 4. The change in potential energy will be, okay, kinetic energy changes from x to x by 4 when electron jumping transition takes place. Then what is the change in potential energy? So for that, see this, we know that potential energy equal to minus 2 into Ke. Let Ke, kinetic energy, equal to x, then potential energy becomes minus 2x. If kinetic energy becomes x by 4, then potential energy equal to minus 2 into x by 4, that is minus x by 2. Now change in potential energy, final value minus x by 2 minus of initial potential energy minus 2x, then we can get 3 by 2x. So what is the option? Option C is the answer. Next, the potential energy of an electron in the He plus ion is minus 12.08 electron volts. Indicate in which excited state the electron is present. Potential energy value is given. Based on that excited state we should find out. See this one, given potential energy of He plus ion, this one, total energy Et equal to potential energy divided by 2. Then we can get total energy, this one. Next, for He plus ion, energy E equal to, what is the formula? Minus 13.6 into Z square by N square EV. So here E means this value, substitute this value, and Z for He plus atomic number is 2, N value we should find out. Then by doing calculation we can get this one. So for third orbit, potential energy of the electron is this one in He plus ion. So third orbit means, what is the option? Option C is the answer. Okay, practice well, you can get good marks related to these energy numericals. Next, say this, the value of double of potential energy of electron in hydrogen atom in its third excited state. In the hydrogen atom in third excited state, double of potential energy of the electron, how much? See this, we know that potential energy equal to 2 into total energy. Here Et means total energy. For hydrogen atom, Et equal to minus 13.6 into Z square by N square electron volt. Here third excited state means N equal to 4. First excited state means second orbit. Second excited state means third orbit. Third excited state means fourth orbit. So N value 4. So potential energy equal to 2 into, in place of Et we can substitute this one, minus 13.6 into, for hydrogen Z value 1, N value 4, 1 square divided by 4 square. So we can get minus 1.7 electron volts. This is the double of the potential energy of electron in third excited state. Next, what is the potential energy of an electron present in N shell of the Be3 plus ion? Already we know that N shell means N equal to 4, Be3 plus ion, Z equal to 4. So energy of N shell means minus 13.6 into Z means 4 square divided by N square. We can get this one. So potential energy Pe equal to 2 into total energy. So 2 into this value. We can get minus 27.2 electron volts. Option D is the answer for this. So practice well. You can get good marks. We will meet in the next class.